Salam sejahtera saya ucapkan kepada Sir Saifuddin. Saya Ernest Olsen, anak Derek, nama matriks 05 DKM 23 F1042. Hari ini kami akan membentangkan tentang understanding defects and distortion in welding. What is welding? Welding is a process of joining two pieces of metal together by melting or fusing them. The metals that are about to be joined is heated to its melting point. When the two metal is cold, it will become a strong joint. Welding are usually used in construction and manufacturing. It is also used in repairing metals and creating structures. Art could also be made by welding. The scenarios. Imagine you are a senior welding engineer at a renowned engineering firm. Your team has encountered a complex welding project where defects and distortion need to be minimized to ensure structural integrity and aesthetic appeal. As a part of your responsibility, you are tasked with delivering a presentation to educate your team about the nuances of welding defects and distortion and strategies to mitigate them. Now I'm going to talk about understanding welding defect and distortion. Welding defects. Number 1, porosity. Porosity is the presence of cavities in the weld metal. It is caused by the freezing in of gas released from the weld pool as it solidifies. Porosity could be affect the structural integrity by reducing its strength and its resistance to various types of stress. This could be defect by observing the weld bits.
Okey, nama saya Atul Laka Anak Anthony dan nombor matrik saya 05 DKM 23F1014. I would like to continue about the welding defect and distortion. So the next defects and distortion is lack of fusion. Lack of fusion occurs when the weld metal does not properly fuse with the base metal because of not enough heat, improper welding technique, or inadequate cleaning of the metal. This could affect the structural integrity by making the joint become weak and the metals welded is easily separated. This could be detected by visual inspection or ultrasonic testing. Okay, next is cracks. Cracks in welding is often caused by base metal contamination, poor joint design, high welding speed but low current, and residual stress caused by the solidification shrinkage. Cracks could impact the structural integrity by reducing the strength of the weld through the reduction in the cross-section thickness. Cracks in welding could be detected by doing visual inspection, dye penetrant testing, and eddy current testing. Next is distortion, where welding distortions occurs during the expansion and contraction of the weld and base metal during the heating and cooling cycles. Distortions could impact the structural integrity by reducing the strength of the metals as a deformed component can no longer support the load it was intended to carry. Distortions in welding could be detected by doing visual inspection as metals distortion are usually easily detected. This is the case study and real life examples. So the project description is the workshop has undertaken a contract to fabricate intricate steel structures for an art installation. The sculptures integral to the public park beautification project demand the highest quality welds to ensure aesthetic appeal, structural integrity, and safety. The types of welding you use is shielded metal arc welding, which is small. So what is the welding defect and distortion encountered in this project is there are a lot of welding defect and distortion encountered in this project. Some of them are porosity, lack of fusion, and cracks. The distortions of metal is also encountered. This is a very serious problem as the structural integrity of the weld is affected and the weld is not visually pleasing. Right. So the lesson learned and the measures taken to rectify this issue is there are a lot of lessons that we had learned from this past project. We had learned about how to address the welding defects and distortions. Some of the welding defect is porosity. We could address it by cleaning or brushing the metal before the metal is welded. The other welding defect is lack of fusion. This could be addressed by using the correct welding parameter setting, and perfecting our welding technique with more practices. Another defects that is accounted is cracks. This could be prevented by preheating the metals, slower cooling rate, avoid high traveling speeds, and use high quality materials. For the distortion problem, it could be prevented by not overweld, use as little weld passes as possible, and balancing the weld near the neutral axis. So importance of continuous learning is continuing to learning is very important. This is said because continue to learn and improve and strengthen our knowledge and increase our knowledge, making us more wiser in life. A wiser self could not make problem solving more easier because a more and effective solution could be brought up.
Okay, my name is Gary Peter. My matrix number is 05 BKM 23F1091. Okay, and today I will be presenting about strategies for mitigation and quality improvement. Way to minimize detect and distortion welding technique. For backstep welding is welding in a back and forth sequence, moving from the end of the joint towards the starting point. This helps disturbance heat evenly. Number 2, track welding. The workpiece is secured by tack weld before the final weld to prevent the workpiece to move around and prevent distortion. Number 3, controlling welding speed. When maintaining a uniform or consistent weld speed, this distribution of heat is uniform and minimize the risk of defects. And number last, pulse welding. Pulse welding allow a more better control of heat input and reduce the chance of overheating and distortions. Next one is pre-welding preparation. Number 1 is cleaning the workpiece. By cleaning the workpiece is free from contaminants such as rust, paint, or oils to prevent defects. Number 2 is material selection. A correct welding materials is important as it should be compatible with the welding properties to ensure proper fusion and reduce the chance of defects. 2 is proper joint fit up. An accurate fit up will minimize the gaps and misalignment, reducing the risk of defects and distortions. Number 4 is preheat workpiece. Preheating the workpiece is important to reduce the thermal stresses and minimize distortion. This is important especially for thicker materials. Post-welding treatment. Post-welding treatment conduct PWHT to relieve residual stresses and minimize distortion. This is very important especially for thicker materials. Second one is surface treatment. Surface treatment such as stress relief coating or protective coating is important to be applied to enhance corrosion resistance and reduce potential defects. Number 3 is pinning. Shot pinning or hammer pinning is applied to reduce residual stresses, enhancing fatigue resistance and minimizing distortions. And the last one is stress relieving. Stress relieving techniques such as vibratory stress relief or thermal stress relief to reduce residual stresses and prevent distortions.